morning, students. This is Anjali, Assistant Professor, Department of CSE, AIML, IARE, Hyderabad. Today's our topic is Statistic for Data Science. So just we will discuss the question bank related to statistics for data science. Previously we have discussed the some flavors of data, then mathematics and probability. Everything we have discussed some questions on the basis of the question banks. So now we will see what are the null and alternative hypotheses, or we can say explain the null and alternative hypothesis by considering the example for a flipping coin. Now everybody knows what is meant by the hypothesis testing. Actually, we can say that the hypothesis testing is decision making process. Decision making process which is help to analyze your sample when you are attempting some when you are finding some result that can easily occur, or we can say the result that are unlikely. So the null hypothesis is the claim that there is no effect in the population. If the sample provides enough evidence against the claim that there is no effect in the population, that means P less than or equal to alpha, then we can reject the null hypothesis. Otherwise, we fail to reject the null hypothesis. So here, if whenever we are talking about the null hypothesis, that means there is no effect in the population. So the alternative hypothesis we can show by using the HA. So HA, it's your answer to your research question. That means we can say there is an effect in the population, and your alternative hypothesis is same as your research hypothesis testing. So in other words, we can say it is the claim that is you are expecting or keeping hope will be true. So alternative hypothesis, we can say that it is the complement to the null hypothesis. And null hypothesis and alternative hypothesis may be exhaustive. That means we can say they cover every possible outcomes. They can recognize, they can predict the outcomes. So there are also some mutual exclusive. That means we can say only one can be true at the same time. Two outcomes cannot be true at the same time. Only one outcome can be true at the same time. So alternative hypothesis HA, yes, there is an effect in the population. Now second one is that if distribution is skewed to the right and has a median of 20, will the mean be greater than or less than 20? So here we have to decide your mean will be greater than 20 or less than 20. If your distribution is the right skewed distribution, then definitely mean will be the greater than 20, and while mode remains to be less than the 20. Next, when creating a statistical model, how do we detect overfitting? Actually, overfitting, we can say it's a term where we are using the statistic that refers some modeling error and that occurs when function corresponds to closely to a particular set of the data. So overfitting sometimes may fail to fit your additional data, and this may affect on your accuracy of the predicting future observation. So overfitting may be identified by checking validation metrics such as accuracy and loss. The validation metrics generally increase until the point where they stagnate or start declining when the model is affected by the overfitting. So during an upward trend, the model seeks good fit, which when achieved causes the trend to start declining or the stagnate. Now if in your data training there are some overfitting, then how you will detect? So detecting overfitting is almost impossible before you test the data. So definitely first you have to test the data, then after testing it is easy to detect your overfitting. And this detecting overfitting will help address some inherent characteristics of the overfitting, which is the inability to generalize the data sets. So the data can be separated into different subsets for making it easy for training and the testing. So data we can split into the two main parts. First one the test set and another one be the training set. So training set generally represent the majority of the available data. About we can say that like 80%, and it trains the model. And the test set represent a small portion of the data set, that is 20%. There are two test sets, one test set and another one is training set. The training set is showing the majority of available data, that is 80%, and the test set is showing the small portion of data, that is showing the 20%. So it is used to test the accuracy of the data it never interacted with before. Now by segmenting the data set, first we can examine the performance of the model on each data to spot overfitting when it occurs, as well as see how the training process works. So generally performance can be measured using some percentage of the accuracy which we will observe in both data set for concluding the uh, presence of the overfitting. So if model perform better on the training set than the test set, then it means the model is likely overfitting. Now, to identify confidence interval about mean, when population variance is known, which distribution is suitable. So, generally here chi-square distribution is very important, and this chi-square distribution we can use. So chi-square distribution is used to find out the confidence interval which is totally related to population, standard deviation or the population variance. Why we are using the chi-square distribution? Because there may also some variability between the sample standard deviation and the population deviation. Now next question, what is meant by imputation of missing data? Why it is bad? So mean imputation. Mean imputation means we can say it's like a mean substitution or mean that replaces missing values a certain variable by the mean of non-missing cases of that variable. So mean imputation generally reduces the variance of the imputed variables. Mean imputation shrinks the standard errors which invalidates the most hypothesis test and the calculation of the confidence interval. Then mean imputation does not preserve relationships between the variables, like we can say the correlations. So mean imputation is used for replacing your missing values by a certain variable, that it will reduce the variance, it will shrink the standard errors, and it will preserve the relationship between the variables, like we can say that correlation. Then missing values in your data do not reduce your sample size. So for example, this is your table A, B, C, 1, 2, 3, 4, 5, like that. So we can say this, we have a one table. This is the table, and we can say that its size is like a 3 by 3. So if one value missed also, it's not reducing the size of particular table. So we can say that if any values missed in your data, it will not reduce the sample size. Just it would be case with list-wise deletion. Or we can say the default mini statistical software packages like R, SATA, SAS, SPSS. So mean imputation replaces all missing value and you can keep your whole database. Next one is mean imputation is very simple to understand and to apply. So more on that later in the R and SPSS example. You can explain the imputation method easily to your audience, and everybody with basic knowledge in statistics will get what you have done. So With the help of the mean imputation, it's very easy to understand, it is very easy to apply. Then if response mechanism is MCAR, so that means the sample mean of your variable is not biased. So what is saying that mean substitution might be valid approach, but in some cases only. We can say in case that univariate average of your variable is only metric you are interested in. Next one, state the case where the median is a better measure when compared to the mean. So mean is better when data follows symmetrical distribution. So when the data are skewed, the median is more useful because mean will be distorted by outliers. And outliers, you know that we can say that like unwanted data. Unwanted data, or we can say the unuseful data. And the median is better measure of the central tendency of the group as it's not the skewed by exceptionally high or low characteristic values. Now the standard normal curve has a total area to be under 1 and it is symmetric around 0. You have to find out that statement is true or false. Actually, standard normal curve has total area to be under 1 and it is symmetrical around 0. It's a true. So, generally the normal curve have the area under unity and the symmetry around the 0 in any distribution. So here all of the measure of the some central tendencies are equal to 0 and due to the symmetric nature of the standard normal curve. Now does a symmetric distribution need to be unimodal? Actually in symmetrical distribution, each of these values is equal to each other. So for example, each of the example up to this point, we have used the unimodal distribution like distribution with only one peak. So however, distribution can also be bimodal and be symmetrical. So here you can see there is a one peak. These both portions are the equal. Can you avoid overfitting your model? And if yes, then how? So here you can prevent your overfitting by just diversifying and scaling your training data set, or we can say using some other data science strategies. So early stopping pauses training phase before machine learning model learns the noise in the data. Now how to avoid the overfitting in machine learning? How we will avoid? First one, cross validation. Second one, training with more data. Third one, removing features. Early stopping, regularization and the assembly. So by using this algorithm, by using these techniques, you can avoid the overfitting in the machine learning. So this diagram is showing that the early stopping, here training set, there is a validation set, number of iteration, and these are the errors. Now how to find the mean length of all fishes in the sea? First, whenever this type of question will come, first you have to think about the confidence interval. You have to define the confidence interval, and here you have to use the confidence level like near about the 95%. Take sample of the fishes from the sea, and it will be better if you will take the number of fishes greater than the 30. After that, calculate the mean length and standard deviation of the length. After finding the mean length and the standard deviation length, you have to calculate T statistics and get the confidence interval in which mean length of all the fishes should be. Now explain the confidence interval in detail. Confidence interval is the mean of your estimate plus and the minus variation in that estimate. So this is, we can say, this is the just range of the values you expect your estimate to fall between if you redo your test within the certain level of the confidence. So we can say that it is the interval, it is the range. So confidence in statistic is another way for describing, for explaining the probability. For example, if you construct the confidence level with a 95%, a 95% confidence level, that means it's showing that you are confident that 95 out of 100 times the estimate will fall between the upper and the lower values specified by the confidence interval. Now your desired confidence interval is usually 1 minus, that is the alpha value you used in your statistical test. So confidence interval is equal to, here we can say confidence interval is equal to 1 minus alpha. So if you use the alpha value for value of p less than 0.05 for statistical significance, then your confidence level would be 1 minus 1 minus 0.05, that is 0.95, or we can say the 95% confidence interval. So when do you use the confidence interval? So you can calculate the confidence interval for many kind of the statistical estimates, like if proportions, population means, differences between population means or proportions, then estimates of the variation among the groups. So these are all point estimates, and you don't give any information about the variation around the number. So confidence interval are useful for communicating the variation around the point estimate. Now explain the sampling data with its types in detail. So sampling data, or we can say data sampling, is just a statistical analysis technique which is used for select, manipulate, analyze the representative subset of the data points. And these data points are used for identifying the patterns, trends which are available in your training data set. So when you conduct some research about group of the people, it's rarely or it will find that you are collecting data from every person in the group instead of you select a sample. Here you are not selecting the sample, you are collecting the data from each group. So sample is just a group of individual who will actually participate in the research. Now to draw valid conclusion from your result, you have to carefully decide how you will select sample that is representative of the group as a whole. So this is called the sampling method. So there are two primary types of sampling methods that you can use your research. First one, probability sampling and non-probability sampling. So probability sampling just involves some random selection, and that will allow you to make the strong statistical inferences about the whole group. And the non-probability sampling, it will involve some non-random selection which is totally based on the convenience or other criteria, and it will allow you to easily collect the data. Now what are different types of the correlation? So the statistical tool that help in the study of relationship between two variables, that is called the correlation. So it helps understanding the economic behavior of the variable. Now according to Eller Corner, if two or more quantities vary in sympathy so that the movements in one tend to be accompanied by corresponding movements in other, then they are said to be the correlated. In other words, we can say Croxton and Cowden, when relationship is in quantitative nature, the appropriate some statistical tools are used for discovering and measuring the relationship and expressing it in the brief formula, that is called also correlation. Then according to A.M. Tuttle, the correlation is just the analysis of the covariation between two or more variables. Now there are different types of the correlation. Positive and the negative correlation. Positive correlation means when two variables move in the same direction. And negative correlation, this is negative correlation. So when two two variables move in opposite direction. Then after that, linear and non-linear correlation. Linear correlation means when change is one, variable tends to bear a constant ratio to the amount of change other variable. So that means it will affect of one condition to other. Non-linear correlation, when change in one variable does not bear constant ratio to the amount of change other related variable. Then next one is simple, multiple and partial correlation. Simple correlation means when only two variables are the study. So that is simple correlation. When relationship among the three or more than three variable is studied, so that is multiple correlation. And when relationship between two variable is examined keeping other variable as a constant, so that is your partial correlation. So that means there are three types of the correlation: positive and negative correlation, linear and non-linear correlation, and a simple, multiple and a partial correlation. Now, what are the properties of the point estimators? So, point estimators are just functions that are used to find approximate value of a population parameter from random sample of the population, and they use sample data of population for calculating your point estimate or statistic, which will serve the best estimate of a known parameter of the population. Now here you can see that there is a minimum value, this is minimum, mean and the max value. This is your sample used as a point estimator for the population. This is your population. So that range is -1 to +1. Now there are different properties of the point estimator. First one is the bias. Bias of the point estimator is defined just the difference between the expected value of the estimator and the value of the parameter being estimated. And when the estimated value of parameter and the value of the parameter being estimated are equal, estimator is considered as unbiased. Next, consistency. Generally, consistency tells us how close the point estimator stays to the value of the parameter as it increases in the size, and the point estimator generally require large sample size for it to be more consistent and accurate. Then most efficient or unbiased. The most efficient point estimator is one with the smallest variance, all the unbiased and the consistent estimators. So the variance measures the level of dispersion from the estimate, and the smallest variance should vary at least from one sample to other. So these are the references. You can go through this. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.